Hi, welcome back. As you can see, I'm feeling a little bit ambitious about this project and hoping to get it finished within about hopefully in less than an hour. So let's just go ahead and continue where we just finished. We basically just got pretty much another phase of the project done by getting the sets combined, but now we need to kind of go into that that same code, and we need to basically use kind of for every iteration we have of this being done, we combine our sets, and then we want to, according to that, we want to kind of remove whatever walls that need to be removed from our screen. So let's just start off, instead of worrying about kind of a matrix that we're going to store the actual walls in, let's just try outputting to the screen, since it'll give us immediate debugging information, and then we can always just add a matrix later if we want to add walls that we can detect. Because it's essentially the same thing, but it's harder to get the immediate feedback. So yeah, we'll just go ahead and do that. I'm actually uploading episode 23 right now because I just finished it, and I'll get that set up. But while that's being uploaded, might as well just continue this episode 24 right here. So yeah, let's go ahead, and if we combine two rooms together, what we will do is we will say, so for y and x. Okay, so here we kind of remove. What we want to do is in this, no, not in this, is, okay, here. This is where we do it. Okay, so if g does not equal f, then that means we're removing the wall, basically. So it has to kind of, I guess, if it belongs anywhere, it kind of belongs here. So basically what we need to do is, if we find out that we need to remove a wall, really this g does not equal f thing, that's actually kind of important, because it kind of says whether we should remove the wall or not. Because we're only going to remove the wall if they are different numbers. If they're already the same number, then that wall actually, it'll ruin the maze if we take that wall out. So we have to leave the wall there. So we're just going to remove the wall if those two numbers are different. Okay, so how are we going to remove the wall? Well, quite literally, I want to just put an output statement right here, and I want to say, well, if I want to delete the wall to the right of wherever we are, and so that's the problem with that is is I actually have to undo the whole wrapping effect again, because I want to subtract from, I want to get my original values again for D and E, so I might as well store them in something like, I don't know, like a temporary I guess I could store them in something. I'm saving D and E, right? I don't want to use more variables because it makes it harder to combine this program with other programs later on, and it makes it messy. Which is a bad reason. But we'll do that. Or we won't. I guess we won't do that. We'll just revert it. So here we incremented e. So we'll just do e minus 1 stores e, and then if e equals 0, then I should have done up and to the left. Anyway, it doesn't matter. If e equals 0, then that means we're going left, and that means we want to wrap on the right side, so then 8 stores e. And now we need to convert our d's and e's to an actual mapping, and then I guess add 1 to the e. Which is kind of funny because we just subtracted 1 from it. But anyway, we gotta multiply them by 2. So 2, or actually, you know what, we might as well just do it here in the output command. So we might as well just do 2d here, and then 2e plus 1, and then a space. Okay, and then down here, it's funny that I just ended the last episode, and the reason why it's funny is because I was actually only a few lines away from having a visible maze, I think. But we'll see. We'll find that out. If G does not equal F, okay, then for here, we want pretty much the same thing. So we're going to do, for here we're going to do 2d plus 1, and then we're going to do 2e, and then we're also going to do a space. So those will delete the walls underneath. I want to subtract 1 from d here, so d minus 1 stores d, and then if d is 0, then we have to set 4 as d. So let's just go ahead and run maze. Here we go, and we have a domain error, and I'm guessing it's on the output command, so we must have done something silly here. So right. So okay, so the deal is, so I'm doing something wrong already. I know I'm doing something wrong here because this actually this can't be correct. So let's figure out exactly what I'm doing. So D and E are going to represent these kind of rooms. So if D and E are 1, 1, when I multiply those by 2, it's going to be 2, 2. So it's actually going to just like be here, which already is incorrect. So I think I need to subtract. I think what I need to do is I need to subtract 1 from them before I double them. And then add 1 back, and then add 1 for whatever wall it is. So for example, so this is 2, 2, right? So the double of that is 4. No, because if I subtract 1, double this, 2, 3, 4 would be here. But 3, 3, double that would be 1, 2, 3, 2, 3, 4, 5. Right. So if it's the third room, I only want the fifth one. So what do I need to account for is how many walls there are to my left or above me. And if I'm at 0, there are no walls. Or if I'm at 1, there are no walls. So 1 should actually stay the same. 2 has 1 wall to the left. So I think I'm doubling... Okay, so I'm doubling whatever's to the left of me. So I'm subtracting 1, doubling that, and then adding 1. So 2, 2, 2. So 1, 2, 1, 2. Right, this is a permanent wall. Okay, so 2, 2 should be here. So if you subtract 1 from those and double it, then you get 3, 3. Okay, yeah. So actually what I need to do here is I need to do 2 times d minus 1 plus, in this case it would be plus 2, and then 2 times e minus 1 plus 1. Right? If I'm not sure if that's very obvious or not, but I'm pretty sure that's how it needs to be done. Before the part that I multiply by 2 is less than 1, so this part is going to be similar, and then I'm adding 1 because of that, and then I'm adding another 1 here because I'm already adding 1 because I'm trying to select the wall. So it would be plus 2 there. So let's try that. Okay. It looks like what I thought might happen might be happening. We might actually be generating a maze right now. And actually that would be really cool, because this is the first time I've actually ever generated a maze like this on my calculator. I've definitely generated some pretty neat mazes on my computer, but not on my calculator. So this is a problem. I don't know why this happened, but that's not good. This is a problem, and this is a problem. Okay, well, there was no domain errors, so apparently all my numbers were within bounds. I don't know why this didn't connect, though. I don't get that. That doesn't make sense. No, it didn't work. Is our matrix 8? It shouldn't be rewritten or anything, so should all be zeros. Okay. Our list 1 and list 2 should be empty. Empty. Why? Why? Oh, right. They're not necessarily going to be empty. They're just going to be rewritten over. I forgot about that. Did I use any variables that I wasn't supposed to use? That's not what's supposed to happen. It's not supposed to make a non-maze, it's supposed to make a maze. Oh, you know what? No, because if that was all connected, if that was I'm not sure how this is. How exactly this is working. But basically this, like this room right here should be technically connected to here by way of wrapping. But I don't get how that room wasn't connected. If it combined, am I doing the coordinates wrong? If two rooms combine, they should delete the wall between them. Yeah, that definitely should be happening. If that's not happening, then something silly is going on. I don't know how that's possible though, because if it's not crashing, if everything's within bounds, how could we be off with coordinates? Something else must be wrong, because that is kind of silly. Yeah, I don't know. I really don't know how that's possible. Oh well, good thing we were really close to being finished, because I might have to spend a little bit of time debugging this. Yeah, that doesn't make any sense. 2d minus 1 plus 2. So let's just try something. Let's just try something. I'm sorry. Let's just do something really quick. E and F. Why? Why am I storing... Hold on a second. Why am I storing something based on E? No, F and G. Hold on a second. D and E. No, that's fine. I'm not sure what I'm doing here. No, okay, so F and G are like the values of our actual, like, part of our maze that we're combining pieces together. Let's just go ahead and show ourselves what D and E are again, even though we've done this before. So we're just going to look at what D and E are. And then we're going to go down here and we're going to see we got a space. And we're going to pause here. What is pause 8? I need to remember that. Okay, so we're going to pause. We're going to look at what wall needs to disappear, and then we're going to make sure that that was the wall that disappeared. And if it was, then we're going to go one step further, and we're going to look at the matrix. So 1 and 2. So y equals 1. You know what I just realized was, I'm sorry, I think our maze does work correctly. Ha! I know what happened. This is what happened. I put the instead of deleting the one above us or to the left of us, we're deleting down or to the right, right? So I was that's kind of silly. Yeah. We should change this. I think that solves our problem. I think our maze was correct. We just had the wrong starting picture. We were literally okay, so what okay. I mean, can we just forget that happened? I guess I can't just forget that happened, but I wish I could. Okay, I'm gonna put my bets that this works properly this time, which obviously it has, like, it just watch. It will generate a normal maze this time. Just watch. So I just drew the wrong page. It was generating a maze correctly, but it didn't know where I drew the starting walls and the starting spaces, and I drew the starting walls everywhere in the starting spaces in the wrong spots. That's all that happened. So there we go. This, believe it or not, this maze is fully connected to itself. So, and I'll show you how it's connected. So here we go up here. How is this connected to the rest? Well, if you go up right here, you'll actually come here. And if you go left here, like, well, I guess there's a wall here, so you can't really keep going left, but you can go up, and you can go left here, and then down here. So that, my friend, is a wrapped maze. There is one path between any two given, well, there's one shortest path, I should say. There's one non-overlapping path. There's only one path that you don't overlap yourself to get from any point in this maze to the other point in the maze. So if you say you want to get from here to like here, well, you have to go this way. That's the only way. You can't go any other way. You can't, like, go down here. If you go down here, you're gonna have to come back before you get here. There's no other way to get here. Because of the way it's connected, there's only one unique, I don't know how to, there's only one path that doesn't involve overlapping to get between 2 points. And there we go. We generated a maze, but I don't think we're done yet because we want to have some fun with this. So I want to be able to move around in the maze. You know what I mean? Like, I want to be able to say, like, hey, like, so what I'm going to do is I'm going to create a matrix. And it's going to be 8 by 16, so it's going to be the size of the screen. I'm going to store it in matrix B. Dimensions of matrix B. Okay. And then I'm going to put a 1. I'm going to fill. So I'm going to do everything that we do to the screen, I'm going to do to the matrix. So I'm going to fill the matrix with 1s. Okay. And then here I'm going to say 0s into the matrix. Yep. Okay. And it's funny how I can't believe I was debugging something that didn't need to be like, I'm sorry. I just wasted so much time not realizing how dumb of a mistake that, like, how silly. I had started off drawing that thing. But anyway, here we go. We have an output. And, you know, I just want... I should store these into values. I really should. I really should. In fact, what were our temporary... Were we using temporaries? I think we should be able to have temporary, like S and T or something. And then I'll use like N and O to like calculate where our guy is when we move around or whatever. We'll see. But anyway, what's nice about this program right here is actually it's kind of standalone from being able to play with it, because once we create a maze, like, we don't need to run this code anymore. We just create it once, and then we have like we have this matrix as our output. And so if we do it properly, we should be able to just use this program as an extra thing and then go back to our other programs, I guess. You know, that's sort of how I'm thinking we might be able to implement it pretty easily with our Zelda game. Is we need to do that basically. It's so hard. It's so difficult. TI calculators are I had fun with them when I was younger, but they're also pretty evil. So we're going to put that as T, which represents our Y, and then S, which represents our X. Yep. And then we should be able to do T, and then S. Excuse me for a second, I accidentally left my alarm clock on. Output, and then I'm going to store 0 into that part of the matrix of B. Okay, so there we go, we have that. So S and T is what I'm using. And we got to do our E side up here with duplicated code. Here we go, so 2 times D minus 1 plus 1. And that's our Y, which is our T. 2 times E minus 1 plus 2, and that's our S. So here's our T, here's our S, and then we store 0 into the matrix B, TS, right. Okay, we need to switch this. I always get this wrong. I don't know why. I don't get why I always get that wrong. Okay, so here we go. It's probably because like I expect that you pass the matrix first, since it seems to me like it's a primary variable. And then you're performing like an operation on that variable, which you pass the number. So it's like, why do you pass the number first? I guess that just doesn't make sense to me. So there we go, we ran it, and then if I did this correctly, when I open up matrix B, it should look like 1s and 0s. So let's just go ahead and do that. So that these 1s and 0s should form a maze. Which I think they do. Looks like they do. Okay. Let me recenter that for you. So yeah, it looks like we pretty much did everything we needed to do. Now we can do something that's completely separate from the rest of the program, which is to go all the way to the bottom, and then just to play with that matrix, just to play with just to treat it like it's Zelda, I guess. So we can just kind of start at the beginning at 1 1 or something. So we can just say, or 2. Well, hold on. Every other variable should be, since it starts off like a checkerboard. So 3 3 I guess would be a good. So 3 stores X, 3 stores Y. And then output Y X. I guess we'll be an 8 just for fun. We're usually a theta, aren't we? We're an 8, and then we'll just do while 1, and we'll say get key stores A, repeat A, get key stores A again. And okay, so this just gets a key, and then the keypads are numbered, so we have 21, 22, 23, 24, 25, 26, and then 34. So 24, if A equals 24, then we'll just subtract 1 from X, minus 1 stores X. If X equals 0, then 16 stores X. If A equals 25, then Y minus 1 stores Y. If Y equals 0, 8 stores Y. If A equals 26, X plus 1 stores X. If X equals 17, 1 stores X. If A equals 34, Y plus 1 stores Y. If Y equals 9, 1 stores Y. Okay, so we've made it so that we can hopefully move around. So we're going to store 1 into T and S. Well, unless we switch the X and Y. Okay, so output T S space, but only if X doesn't equal S or Y doesn't equal T. Okay, so if they don't match, then we'll put a space there, and then we'll move around. And before we move around, we save them. So X stores S, Y stores is T. See if that works. So we'll generate the maze really quick, and then we should see an 8 appear. When it's done, we'll see an 8 appear right here. So just keep watching this spot right here for an 8. Oh, I meant right here. Apparently. Okay. And then, well, I shouldn't be able to walk on the walls, but anyway, I can traverse around, and I can just walk over the walls, which is incorrect, but that's okay. I can fix that really quick. I should put some sort of, I guess, end to the maze. I'm not sure how I should go about doing this. Yeah, so pretty much I want to put like an end to the maze. And what's funny is I can actually use the set algorithm. I can actually change that a little bit to make the maze specifically harder for where our start and ends are. So yeah, if matrix B yx equals 1, then we have to go back to where we were. So x and t get stored into x and y. So now we're trapped, but we want to make something interesting. So let's put an end to our maze somewhere. So somewhere between. So I have an idea. So what we're gonna do is we're going to right here. We're gonna do something interesting, and we're gonna say if we reach the end, we want to like have a reward, but we want to be able to make it so that it's kind of random where we have to end up. So we kind of start in that 3-3 position, but we want to kind of, I guess we don't have to make it completely random, but we can, I guess we should just put the end. So 3-3 is kind of like the second position, right? So out of 4, we want to be going down. We want to be the 4th. We want it to be in the 4th position, but going right, we want it to be. We want to add 4 instead of adding 2, so we want it to be 6th. It's a 6 out of 8 positions. So we want it to be 2. So 11, I believe. I believe it's 11. And that sounds correct because it is an odd number. And then going down, we want it to be the 4th position, right? So we want it to be 7. So 7 and 11 will be kind of like the furthest point, at least. It might not be the longest maze run we have to do, but it'll be like the furthest point in, just by area wise. It's the furthest point. So I don't know what the furthest point in the maze would be. We would have to implement maybe like a depth first search or a breadth first search or something to do that, or we'd have to like alter the maze generation algorithm, which I don't think that would necessarily work, because I don't think it keeps track of the right information, or it would change how the maze would appear, like it changed the nature of how it generates. So we might just do another episode later and do like depth first search. But yeah, let's go ahead and let's just say 7 and 11 are our special values. And yeah, we'll just do that. 7, 11, and then we'll just put a theta because we're trying to find our identity, right? So we lost our identity, we're stuck in this maze, we're trying to find our identity, I suppose. We shouldn't be able to go through walls or anything, so that spot should be a 0, 0. So it doesn't really matter where we put this, we could just put it here. But anyway, if we just say if y equals 7 and x equals 11, display you win with maybe an explanation or something. Exclamation point. And then I want the I guess the program should stop there, or it should just start a new maze, I guess. But we'll just stop it there. And make whoever runs it, they'll just have to press enter, just run the program again. So here we go, we generate a maze. We'll just see if it works. So here we are. You can see where my controls are, right here. Okay, so as you can see, I'm right here, and our goal is right there. I shouldn't be able to go to the right or the left because there's walls, but I should be able to go up and down. Should be able to not be able to go up. Can't go that way, so maybe down. Oh, looks like I'll have to go right. Oh, that's a dead end. Okay, so I guess I have to go back. Can't go up. Maybe I have to go right and then down. Can't go down there, so maybe I have to go right and up here. And there we go. We got the end. You win, it says. That was a kind of messy you win screen, so I'm going to go back and just... We don't have to play it again, but it looked like it was nice and fun. Looks like that was a nice game. I kind of should just add a clear screen command right here, though, because that was kind of... That looked kind of silly, so we want to clear the screen before we say you win. So, but I guess just for fun, we can play it again. And yeah, there we go. We have a maze game, and it's finished just like I said in the game in the description. The game itself, at least version 1, you know, at least the initial version is finished. What we can do later on is we can actually find the hardest to get to part of the maze and make that our goal, and we can actually start at the opposite end of the maze. So we can find like the 2 longest parts of the maze, and we can say like, hey, we're gonna make the maze as hard as possible, and then do it that way. Or we can make it maybe bigger than just the screen, or maybe we can combine this with Zelda, and who knows what we'll do. But anyway, that's it. Thanks for watching. I hope you guys enjoyed this episode, and I'll see you later. Bye.